Good afternoon, session chair, co-panelists, ladies and gentlemen. Thank you, Dr. Garg, for this opportunity. I am going to discuss something on which I had opportunity of working for last several years. Basically, how do we really bring back the resource value present in the waste and gainfully utilize it? I had opportunity of working on this particular concept for almost about 20 years now. When I started this initiative, there was hardly any resource, which was getting utilized from waste in the cement manufacture. Whereas currently, we are having almost 4 million tons plus wastes getting into the cement manufacture as resources. These wastes come from industrial, municipal, and agricultural sources. So, and then utilizing this concept, I have been trying to do something more. So that's what I would like to share with you. So first is circular economy. So basically it is an economic system based on reuse and regeneration of materials or products, especially as a means of continuing production in a sustainable and environmentally friendly manner. So a very interesting illustration of the circular economy is a fountain pen. If you compare it with a ballpoint pen, ballpoint pen literally is thrown out after its use. Whereas a fountain pen, it continues. In fact, when I was young, we had a mandate to use a fountain pen at least 5 to 6 years. And in these 5 to 6 years, only thing that was being used or replaced there was the nib, which used to get broken, or the insert, which used to be of wooden or plastic later on, replacing that. So imagine in 5 or 6 years' time, you are utilizing maybe a gram or 2 maximum as a material resource, from the Mother Earth. Today, if you take ballpoint pen, millions of them, they are just getting into the environment. They just get thrown in. And that's the linear economy where, we are stuck and we have to come out of. And that's where the importance of circular economy. What needs to be done? So I have been groomed to look at waste as resource. So first is target. Look at waste. What is the resource value present in that? And then you convert that waste into a resource. So whatever resource value is there, how can you maximize it? How can you utilize it? How can you avoid what is not relevant? How can you avoid what is not resourceful in this particular waste stream? And that's how you start looking at waste and transforming waste into a resource. And that's how, as I said, more than 4 million tons of waste is getting utilized in the cement manufacture. It's getting utilized in different areas also, which I'll illustrate very briefly. But if we want to achieve that, I have come to a conclusion from my experience that 5 I's are required. The first I is intent, that I want to utilize the resource value present in the waste. The second is idea. Once I know that I need to utilize some waste stream as resource, I need to get an idea out of that. How do I convert the waste into a resource? I need inspiration to do that work. I need probably a teamwork to do that work. So when I start working together with that inspiration, we come up with innovations which are workable, viable. And those innovations, then you convert them into implemental solutions. So these implemental solutions are something that we are looking at from the circular economy point of view. Which are the various measures that are promoting circular economy? Is to use renewable power, renewable energy, improve resource efficiency, use secondary materials as industrial manufacturing inputs, use renewable fuels as inputs, carbon capture and utilize it, so that the impact which we are having, the carbon, the climate change impact, we can nullify or reduce it possibly. Why do we want to do this? It's because we are the victim of this particular linear economy. We are the victim of this climate change. We are the victim of these emissions which are happening around us. Earlier days, we used to do some voluntary controls. Then came the rules, and we started controlling as per the regulation. The rules started becoming more and more stringent over a period of time, and they are going to become more stringent in days to come. A stage is going to come when zero waste is going to be the norm. So if zero waste is to be achieved, the only way that we can achieve is through the circular economy. And if circular economy has to be implemented, the best approach is what is called as industrial symbiosis. That means the waste, identify the resource value, convert it into resource and utilize it, so that the waste does not get into the environment at all. Therefore, there is no waste. There is zero waste. So that's the approach that is required to be done. And it is something which is non-existent today. When I give you some examples, you will realize that most of it, we are just discarding. We are not looking at the resource value present in that at all. So there is need to look at these particular waste streams in the form of products. That means, again, you need to invent those particular products, build processes to build those products. You need new applications to use those products. Mobile was not at all an existing product some 25 years back. Today, it's a necessity, it's a required material. Laptops, yes. Take so many of them, they are all today. So the product was developed, the application also was developed, and it has become a part of the whole process. You also need new processes to produce them. So there is a huge requirement of doing research in this particular area. And this research is not going to be silo-based. This research has to be completely collaborative. So various different disciplines have to work together to achieve that. Like today, artificial intelligence is being talked about, which is basically a totally different digital technology, but is playing a major role in various other technologies. So who knows, chemical segment, mechanical segment, I don't know, maybe steel segment, maybe minerals segment, all of them have to start working together to really achieve the utilization that we are talking about. And that's where there's also a need to develop various platforms and tools. Like we have Uber, Ola platforms where, you display your requirement. There's somebody has got that particular fulfillment capability. He comes on the platform, you work together, you achieve what is required. In the same way, there's need. Suppose, assume that there is a waste stream that I generate. I put it on a platform. There's somebody who wants to utilize that particular waste stream, either by processing, or there's somebody who knows how to process that. He also comes on that platform. They work together, produce that product. That product is utilized by somebody, again, who is on platform. So there's a need to develop this kind of platforms, tools, with which, what we are looking at is something that can be facilitated. And in fact, I have been working on this as a developmental initiative. It's called Industrial Symbiosis for Circular Economy. And there's a software that we are trying to build with which this thing is feasible. Some of the examples, how waste streams gets utilized in large quantities. We had these cement industries of the past, 1950s. There was a need for our country after independence to build fertilizer plants. At that time, fertilizer was not urea. It was ammonium sulfate. So if you produce 1 ton of ammonium sulfate, almost 1 ton of calcium carbonate slurry, you generate as a waste stream. What do you do with that? There was somebody who came and who discussed this with cement plant. I'm very proud, ACC Limited, with which I was associated. And ACC, after doing some deliberations, internal deliberations, said, yes, we can produce cement out of this slurry, this particular waste stream. They set up a cement plant adjacent to the fertilizer plant. There was only a pipeline in between, and they continued to produce together the fertilizer and cement for more than 35 years at Sindri. That's industrial symbiosis. The fly ash, the slag from steel plants, the petroleum, coke from the fertilizer, from the refineries, and then now, agricultural waste. Then you have the municipal combustible material from the municipal solid waste, and industrial hazardous and non-hazardous waste. So cement industry is able to utilize all these particular waste as resources. In the process is reducing its consumption of raw materials, the fossil fuels and fossil raw materials. So therefore, if 1 ton of coal probably is not utilized or is replaced with a waste stream, that 1 ton of coal is not required to be mined at all. So that unmined coal will remain forever for the future generation requirement. So our approach in the circular economy is to ensure that we don't exploit anymore the resources that we have, which are given to us by nature. We just use all the possible measures to conserve them. And that's what is the requirement today. You take municipal solid waste, Ma'am Jindal is here, the rules of 2016, where the segregation has been promoted as one of the most important requirements. Why do we do that? Because if you segregate them, then there is an application for every waste stream that gets generated, whether it is organic waste, glass, plastics, recyclable, non-recyclable, the inerts, you name it, everything can be utilized. We had done run a program in a village called Madukarai near Coimbatore. In 2011, we did that particular thing where there's no dump yard at all. 2011 onwards, till today, there's no dump yard. Everything gets utilized. It's called Clean Green Madukarai. And subsequently, Ambikapur, and then you have several towns which have come up now. So it is possible. Somebody was asking question, whether it has to do with the habits, etc. Yes, possible. But the intent, the drive, whatever technological innovations, the implementation methodology, etc., all that is very, very essential. Similarly, dump yards. Today, a large amount of waste from the dump yards is utilized in the cement manufacture as resources. Several big dump yards are getting, completely remedied, and the waste stream, combustible material, is being utilized in the cement plants. So it's possible. You take another very interesting example, red mud. Red mud is a waste stream globally. Nothing can be done. You are just putting them into ponds, or you are dry stacking them from aluminum manufacture. 1 ton of aluminum, 3 tons of red mud. What can you do with it? I had an opportunity of working on this particular project with European Union. And then what we realized is that if you are able to transform this particular red mud from its whatever nature to pozzolanic nature, which can be done, through technological intervention, almost every ton of red mud which is currently getting generated and getting stacked up around in the environment will get utilized as a resource, conserving equal amount of resources that we are utilizing in the cement manufacture. We can use this as also the sand and the aggregate substitutes. But what is required? The intervention. The intervention is process development, the product development. And that's where I think a lot of work needs to be done. And I'm happy that things are happening in that direction. Building industrial eco-parks is going to be very, very essential requirement in days to come. Today, I'm a part of MRII, I'm on their board, and through MRII is an association, a scientific body, which is working with Maharashtra government as a knowledge partner in promoting the industrial eco-parks. So here, waste stream of every industry has an application in some other industry, so they come together. Like I said, fertilizer and cement plant were together to solve the problem of calcium carbonate slurry. We can bring industrial eco parks, we can build them so that the industries which can utilize waste of other industry are part of that particular eco park. And then you start utilizing waste. I don't want to get into this presentation will be available to you, but every waste stream that is coming out of in this particular several waste manufacturing processes that I'm talking about gets utilized. The technologies are there today. And that's the advantage, of going. So this is all I wanted to share. Thank you very much for your time. If there's any question, I'll be happy to answer.